Hello everyone, in this video we're going to explore the quadratic functions in vertex form. Alright, so the quadratic function in vertex form is given by the formula f of x equals a times s minus h squared plus k. Alright. We have two different cases. The first case, a greater than 0. The graph opens upward, right? So it's going to be like this. The graph has a minimum value right here. This is the minimum value, which is the lowest value. The domain of the function f of x is negative infinity to positive infinity, because the graph keeps going up and further to the left, and the graph keeps going up and further to the right. Alright, the range of the function is from the minimum values all the way up. So it can be like this, all the way to infinity, right? So the axis symmetry is s equal h right here. So axis symmetry is going to be right here. Alright, the vertex is right here, h and k. The x-intercept is the zeros of the function. So basically you just let y equal to 0, then you solve for s. The y-intercept, you just let s equal to 0 and you solve for y. Alright, so this is my y-intercept right here. E squared, the function meets the y-axis. Alright, now suppose this function is given by the equation y equals 2 times s plus 1 altogether square minus 8. Alright, now a right here equals to 2, right? Greater than 0. So the graph opens upward, right? The graph has a minimum values right here, right? The minimum values, which means the y values of the vertex. So the minimum right here is negative 8, right? So y equals negative 8. Now the domain is negative infinity to positive infinity. Now the range of the function is from the minimum all the way to infinity, right? So the minimum is negative 8. So you just write bracket negative 8 comma infinity, or you just write y greater than or equal to negative 8, and that's it. Alright, axis of symmetry is s equals h. Alright, so you look at this one, the formula right here. Now keep in mind, in the formula we have the subtraction sign right here. Now we don't see subtraction sign right here. So basically we just rewrite this function. Okay? So y equals 2 times s. Now I need subtraction sign right here. So I put subtraction sign right here. Alright? So you look at this one, because the function is given addition sign. So basically, does that mean I need to put another subtraction sign to make it positive? So it could be 1 right here, right? Square minus 8. So in this situation, h equals negative 1, right? If you match them up with this formula, f of x equals 2 times s minus negative 1 altogether square minus 8. And then this guy right here is the h value. Alright, you see that? So the axis of symmetry is s equal to h equals negative 1, right? So it's going to be negative 1. Now we're going to use the graph of this function to check to see if s equal to -1 is the axis of symmetry. Now we know that the axis of symmetry is the line that split the graph into two halves, right? So keep in mind the axis of symmetry always passes the vertex, right? So it's going to be right here. And the value of axis of symmetry is going to be right here, -1. Yeah, that's right. Now the vertex is h and k. Now h equals -1, right? The vertex is going to be h and k. Now h equals -1 we found right here. K right here. Alright? H equals -1, k equals -8. So it should be -1 and -8. Now we check it, the vertex right here. Right? X equals -1. Y equals -8. So this is right? So the vertex is -1, -8. Now the x-intercept is where the graph crosses the x-axis, right? So we have two x-intercepts right here, right? The first one is going to be -3. The second one is going to be 1, right? So we have the x-intercept, we can write -3 and 1. Or we can write -3, 0 and 1, 0. And the last one, y-intercept is where x equal to 0, right? So you look at this one right here. Y-intercept where the graph meets the y-axis. So y-intercept is going to be -6, right? So you can put -6 here, or you can write 0, -6. Now, the y-intercept where x equal to 0, so I can check it, plug in 0 for x, right? So I have y equals 2 times 0 plus 1 square minus 8. So it's going to be 2 minus 8. So it's going to be -6. So that's exactly it right here. Alright. Now you can use the TI-84 plus CE calculator to check for the x-intercept, right? The minimum value right here, right? Okay, you do exactly what I did in the previous video about the quadratic functions in standard form. Now let's move on to the second case. If a less than 0 and then the following change. The graph opens downward. The graph has maximum value, right? The maximum value right here. And the graph opens downward. The domain still the same. The range is going to be -infinity to maximum, right? So it's going to be like this. The vertex, same thing. The x-intercept and the y-intercept, you do exactly the same thing, right? So let's take a look at this example right here. So suppose this function is given by the equation y equals -2 times s minus 1 altogether square plus 8. Alright, so I'm going to copy this function over here. So it turns out to be y equals -2 times s minus 1 altogether square plus 8. Now I need to match them up, right? A equals -2, which is less than 0, right? So the graph opens downward, which is right? Next one, h equals 1, right? I have h equal to 1. Now k equals 8, right? K equals 8. Okay. The domain is going to be -infinity to +infinity. The range is going to be from negative infinitive to the maximum. Now the maximum right here equals to 8, right? So you can write the range as parenthesis negative infinitive to 8 bracket. Or you can write y less than or equal to 8, right? Because it's from 8 all the way down. Now the axis of symmetry is s equal h, but h equals 1 right here. Okay, so the axis of symmetry s equal to 1. Alright, so I'm going to sketch the axis of symmetry. Now, axis of symmetry is the line that split the function into two halves, right? So it's going to be right here. And s equal to 1 right here. This is s equal to 1. Now, the vertex is h and k. So this is the vertex, right? It's going to be 1 and 8, right? So 1 and 8 right here. H and k. 1 and 8, right? So it could be 1, comma 8. The x-intercept right here and right here. So x-intercept equals negative 1 and 3, right? So you say negative 1, comma 3. Or you can say negative 1, 0, and 3, 0, right? Now the last one, y-intercept, you just let x equal to 0 and you solve for y. Actually, the y-intercept is going to be 6 right here. You can see it. So y-intercept is 6, right? So you can say 0, comma 6. Alright, so now let's x equal to 0 to solve for y to see if we get the same y-intercept, right? X equal to 0, so we have y equals negative 2 times 0 minus 1 square plus 8, right? So it's going to be equal to negative 2 times negative 1 square plus 8, right? So it's going to be negative 2. Negative 1 square is going to be 1 plus 8, right? So it's going to be negative 2 times 1 is going to be negative 2 plus 8. So it's going to be 6. And that is the y-intercept. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.